Okay, so today we're going to talk about Mersenne numbers. So we have to pick one of our Mersenne numbers to exemplify the category. Now, Brady always makes me do this, so I've decided to pick 31 because by the time you watch this video, I will be 31. So it's a nice personal number for me. So 31 is our example of a Mersenne prime. So a Mersenne prime is a prime number to begin with, like 31. 31 is a prime number. A prime number is, as you probably know, a number that can only be divided by 1 and itself. The first few prime numbers are 2, 3, 5, 7. 31 is a prime number, but it's a special type of prime number because it's one less than a power of 2. What are the powers of 2? You've got 2, you've got 4, you've got 8, 16, 32, and so on. Okay, so that's just 2 times 2 times 2 times 2 times 2. That's the sort of thing. None of these are prime numbers, but let's have a look at one less. Well, 1. Now, if I'm honest, we don't say 1 is prime. There's a special reason for that. But let's have a look at the others. 3 is a prime number, and it's 1 less than the power of 2, so that counts as a Mersenne prime. 7 is a prime number, and it's 1 less than the power of 2. Fantastic. 15, now that's not a prime number, so that does not count. And 31, there you go, that was our example of a Mersenne prime. Now, there aren't many of these Mersenne primes. In fact, there's only 47 Mersenne primes. Now, they start off as 3, 7, 31, the next one after that is 127. So let's have a look at the next couple. Powers of 2, 64, 128, and well, this is 63, and that's not prime. But this is 127, that is prime. So it's one of our Mersenne primes. They're called Mersenne primes because they're named after a French mathematician called Mersenne, who was a monk, a mathematician and a musician and a fan of alliteration. His favourite cartoon was Mighty Mouse, his favourite film was Mad Max. So he was in contact with a lot of other mathematicians around the world, and he was trying to make a list of this special type of prime number, and that's why they're named after him.
Are they useful? Are they used by code breakers? Are they used to make better iPads, or are they just a game for smart mathematicians like you?
Well, prime numbers are obviously very useful to mathematicians. They're famous, and they're famous for a reason. Mersenne primes are a special type of prime number. Something very special about Mersenne primes. They are related to the perfect numbers. We've talked about perfect numbers before. They were 6, 28, 496, 8,128. They were known by the ancient Greeks. They were given this idea that they were perfect, unique. Mersenne primes and the perfect numbers are two sides of the same coin. Let me show you why. If I pick a Mersenne prime, let's call it M for Mersenne prime, okay. So M is our Mersenne prime, times it by M plus 1, divide by 2, and that will give you a perfect number. Let me show you. 3 times 4 divided by 2. That's 12 divided by 2. That's 6. That was the first perfect number. Okay, let's try the next one. 7. 7 times 8 divided by 2. That's 56 divided by 2. That's 28. That's the second perfect number. 31. Same thing. 31 times 32 divide by 2, and that will give you the third perfect number, 496. And let's try 127. 127 times 128, and halve it. It's 8,128. Two sides of the same coin. Right, so you can help to find the next Mersenne prime. It's called the Great Internet Mersenne Prime Search, a great website with an unfortunate acronym. It's at mersenne.org, and you can try it yourself, download the program. It uses collaborative computer power to find the next Mersenne prime.
Why? Why should I do that? Why should anyone do that?
For the glory, because mathematicians will thank you for it. Like the perfect numbers, we don't know if there's infinitely many perfect numbers. We don't know if there are infinitely many Mersenne primes or not. So that's another open question, something that maybe, hey, you could work out.
What's it going to take to work that out? How will that question ever be answered?
It's not going to be easy. It's not going to be obvious. It's going to take a different way of looking at things, coming at it from a different angle, something that other people haven't tried yet. Maybe not your usual school maths, but something else. Whatever it is, something we haven't tried yet.
The man or woman who does it, what will it mean for them? If a man or a woman comes up with that proof, what will happen?
If you do come up with that proof, you will have glory thrust upon you. You will be famous for coming up with such a proof, something that has eluded mathematicians for hundreds of years.
Is it something you can have a hunch about?
Yeah, I think technically we would have to be Mersenne prime agnostic, but it's definitely something you have a hunch for. Mathematics is done that way. People think mathematics is a dry subject, that it's logical, but people have intuition. They have to pursue their intuition. So if you ask me, I would say, yeah, infinitely number of Mersenne primes, yeah, I would think so. I might be wrong,